Centipede.
Sup YouTube, Official Gaming Network, and welcome to episode 5 of our Jetpack Joyride game in Java tutorial. Last episode, we created a window for our game. This episode, we're going to be creating the thread for our game. Now, what a thread is, it's pretty much a process, not a processor, just a process. Now, I'm just going to tell you right off the bat that every app that you're running right now, like the browser that you're using to view this video, when you actually run our Java game, I don't know, any app that you have open has at least one thread working inside of it. And a thread pretty much is a process that allows us to do multiple things simultaneously. Now, we're going to create a thread inside of our Java project, which when runs will already have one thread, even if we don't create one. I don't think I explained that very well, so I'll explain it again. So you can tell by now that I pretty much said all apps that we run has at least one thread working in them. So that means if we actually run our Java game at the moment, it actually has a thread working with the game, although we can't see it and we don't really know what it does. But the thing is, our Java project has a thread that works with the game. Now we're going to create a thread inside of our Java project, so we're pretty much creating a subthread. Now if you're a bit confused about what a subthread is, think of it as like, remember when we talked about inheritance and we made our game class a subclass of canvas and using canvas as a superclass? Well, think of that. Think that the thread in our Java project that we actually run is the super thread, and the thread that we're going to create is the subthread. So yeah, basically think of it a process, which is what a thread is, inside of a process, and both of them will allow us to do multiple things at the same time. Now, the reason why we're creating a thread is because we're using it in preparation for our game loop we're going to be implementing next. Oh, sorry, getting a call on Skype. I'll be right back. Now, I was going to explain what a game loop is. I'm actually going to explain that in the next episode when we're actually going to create our game loop. But for this episode, we're just going to be creating the thread that we'll actually use for our game loop. So, yeah. Now, we're going to create one variable and one object. Under our dimension size, we're going to make our object private. Our object is going to be a thread, and we're going to call it thread. Now the thing is, we don't actually have to initialize or finish creating objects on the same line. So by typing this, we're creating a thread object, but you could say it's not quite finished or initialized yet. And what we can do is that we're going to actually set thread equal to a new thread in another line of code. So I'm going to give you an example of this by creating a game object. So we can actually let's just make a public game object. We're going to call it game. And then we can just put a semicolon on the end, and that will, you know, as I said before, it's kind of like half created, like it's there, but it's not fully created and it's not doing anything. And in our constructor, we can actually set game equal to a new game there, instead of having to do it on the one line of code. And we can do this for variables as well. So I could make a public integer called game, and in a different line of code, I could set game equal to, let's say, 34. Yeah, this will work for any variable and any object. So yeah, we're going to do that for a private thread we're going to be making. And we're also going to create a boolean. Now, I've explained what a boolean is before, but I'm going to give you a very brief explanation of what it is again. A boolean is a variable in which that it can exist in two states, true or false. That's it. Alright, so its value has to be equal to true or has to be equal to false. We're going to create a private boolean under our private thread, and we're going to call our boolean running and put a semicolon on the end to show that we haven't actually created yet. Now, if we actually don't fully create a variable on the one line, Java will actually set it to something by default. So by default, a boolean will equal to false. By default, an integer would equal to 0, and by default, a string would equal to just nothing, just no characters at all. So yeah, by not fully creating our boolean, because Java has default values for different types of variables, Java would automatically set our running boolean equal to false. So now we're going to create a method. Our method is going to be a public void, so we'll type public void, and we're going to call it start, and then give it some curly brackets to represent the method's body. So now, in our start method, we are going to we'll make our public void private, because we're not really going to be using it outside of our game class, so what's the point of making it public? So yeah, in our private void start method, we are going to actually set running equal to true. And to do that, we can set running equal to true. So from this line of code on, our running, a boolean, will always equal to true unless we set it back to false again. And actually, at the top of our start method, we're going to make an if statement. Now, what an if statement is, an example of it would be this. If, let's say, if 3 equals 4, then you'll give the if statement a body like we give constructors and methods bodies. So what the if statement does is that it's checking if 3 is equal to 4. And if that's true, then all the code inside the if statement will be executed. So for the lines of code inside the if statement to be called or executed, the thing we are checking in our if statement has to be equal to true. If it equals false, then Java will ignore this entire if statement and the code inside of it. Alright, so that's a brief explanation of what an if statement is. And what we could do is that we don't actually have to create a body for our if statements. If our if statement has one line of code inside of its body, we can actually type the code we're going to execute right next to the if statement we're creating. So because my example if statement has one line of code inside of it, we can actually put this line of code at the same line as our if statements. And that will work exactly fine. So yeah, that's pretty much what if statements are. Alright, and in this if statement, we're going to be checking if running is equal to true. And to check that, we can simply just type if running. Now for booleans, if we put just the boolean's name inside of the if statement, then we're pretty much telling Java to check if running is equal to true. And if we do the opposite, the way we do the opposite is that before the name of the boolean we want to check is equal to true, we have to put an exclamation mark. So by doing this, we're checking if running is equal to false. So we can still do another way. We can type if running, then 2 equal signs, so is equal to true. And by the way, we use 2 equal signs where we're checking things in an if statement, and we use 1 equal sign when we're actually setting variables or objects. So yeah, just to clear up any confusion here. So we could type if running is equal to true this way, which is takes up a bit more time. Yeah, this is a more efficient way, just typing if running, because just by typing if running, we're already checking if running is equal to true. And we're not actually going to give our if statement a body, because we're only going to be executing 1 line of code inside the if statement. So after the if running if statement, type return, then put a semicolon on the end. Now what return does, it pretty much gets out of the method we are in. Alright, so by typing return in any part of a method or constructor, we're pretty much just telling Java to immediately get out of this method and not worry about any more code that is below it. So if running is equal to true, then Java will pretty much get out of this private void start method, and it will ignore the running is equal to true line of code and the other code we're going to be typing. Alright, so now we're going to type more lines of code. We're actually going to set our thread equal to a new thread. So we're going to type thread is equal to a new thread. And now we can actually give our thread a name the same way we gave our JFrame a name. So we can call our thread thread, and we have to put that in a string using 2 quotation marks, then whatever you want to type inside of those quotation marks. And now, one of the constructors in the thread class actually have two parameters, and we're going to be using that constructor. So, for that constructor, we need an object that implements the runnable interface. Now, I'll explain what that means in a second, but for now, we're just going to type this. And by typing this in Java, we're pretty much referring to the class. So by typing this, we are referring to our game class. And then to initialize the second parameter, we put a comma after the first parameter, and then you type whatever the other parameter is. In this case, it's our name for our thread. So we're going to call it thread. And the reason why we get an error is because, as I said before, the first parameter has to be of a class or object that implements the runnable interface. Now, to implement the runnable interface for our class, so just letting you know, when we're trying to extend a class, we put extends, then whatever class you want to use. But whenever we're trying to extend an interface, which is what we're going to be doing now, we have to use the word implements instead of extends. Now, after extends canvas, we're going to type implements, then the name of the interface we want to use. So we want to use the runnable interface. And as you can see, we actually get an error, and I'll explain why in a second. Now, what an interface is, it's pretty much like a class, but it can only contain methods that have no code inside of them and variables. And by implementing an interface, we're free to use the variables in whatever way we want, except for changing the value of them. And because, as I said before, the methods actually have no code inside of them, we can add in the code we want to use for those methods. Now, by default, every variable created within an interface is public, static, and final, like our width and height variables, which are also public, static, final variables. So that's pretty much the reason why I said we can't change the values of variables that have been created inside an interface, because that variable is final, and when we create a final variable, we can't change the value of it. Once we set it, it's final. And the methods inside interfaces by default are public and abstract. Now, what an abstract method is that we're going to actually talk a bit more about inheritance again. Sorry if this is kind of annoying you, but inheritance is going to come up a lot when you're programming in Java. So what an abstract method is, it's pretty much a method that is forced to be put inside of the class that is implementing the interface or class. So pretty much, let's say our canvas class had an abstract method called test. If canvas actually did have an abstract method called test, and we don't have a test method inside of our game class, we would get an error, because no matter what, it has to be inside of our game class. And because I said all methods inside of interfaces are public and abstract by default, all methods that are created inside of our runnable interface have to be into our game class, no matter what. If we don't, then we'll simply get an error. So, our runnable interface has a method called run, and that method is actually a void method. So we're going to implement it right now. Under our game constructor, we're going to type public void run. And if we go to the top of our game class, as you can see, we don't get an error under game anymore, because we're using all the abstract methods needed. An abstract method isn't only used inside of interfaces, it can be used inside of classes as well. Alright, so now we're going to type 2 more lines of code. First is that after we create our thread, it's there, but because, as I said, a thread is a process, all processes need to be started. So yeah, our thread is pretty much there, but we haven't actually started it. So to start our thread, we're going to call a method inside of our thread class, which is called start. So we'll just type thread dot start. Oh, it's loading a bit here. Alright, and there we go. And by typing this, we're actually going to start our thread and make it run. But the problem is, with our start method, the code inside of it never actually gets executed, because we haven't called our method. And by calling a method, we execute all the code that's inside of it. So to call our start method under all our JFrame things, we're just going to type game, referring to our game object, game.start. And now we'll call our start method inside of our game class, executing all the code that's inside of here. So if we run our game, so yeah, there's no visual changes, but there is a change, but there is actually a change in the code. Now, in the next episode, we're going to actually be using our thread to make a game loop, because right now our thread is running, but it's not doing anything. So next episode, when we create our game loop, we're actually going to put our thread to use. So yeah, I'm going to wrap up this episode here. If you enjoyed, feel free to leave a like, a comment and subscribe. If someone you know is interested in learning how to program a game in Java, or is interested in watching game devlogs, please let them know about this channel. And if you have a Twitter account, please feel free to follow me on Twitter. So see you guys soon. Bye.